You want to cut through the noise, get the essence of something complex, and feel like you actually get it. That's what we try to do here.
Yeah, really boil it down.
So today, we're diving into a really big idea, this concept of a truly interconnected global energy system.
A massive undertaking, potentially.
Exactly. And our guide for this deep dive is a specific academic paper called On the Techno-economic Benefits of a Global Energy Interconnection.
Right.
We're going to unpack its main arguments, its findings, and really look at whether linking up the world's major power grids actually makes sense economically and technically based on what this study says.
Yeah, this study on the techno-economic benefits of a global energy interconnection, it digs into a pretty fundamental question for our energy future, doesn't it?
It really does.
I mean, what are the potential pluses of wiring up the whole planet's energy regions? The researchers explore, why we're even talking about this and what the payoffs could actually look like.
Okay, so let's start there then. Why even think about this? What's the big push, according to this study?
Well, no big surprise here. This study points straight at climate change as maybe the primary driver.
Right, defossilization.
Exactly. We need to slash our fossil fuel use by mid-century. That much is pretty clear. And the researchers, they look at things like carbon capture and storage, CCS, but they highlight the high costs.
Yeah, and it's not a silver bullet anyway, is it?
No, exactly. It doesn't solve every environmental problem, and it's not really practical for everything, like running our cars directly.
Okay, so CCS has limits. What about other cleaner options mentioned in the study? Where do they fit in?
Well, the study touches on bioenergy, but notes there are real limits on how much we can sustainably produce.
Sure, land use and so on.
Right. And it also looks at nuclear. Current fission tech. It has its challenges, cost, fuel, waste, and fusion. Well, fusion's still a ways off, isn't it?
Still feels like science fiction sometimes.
Kind of. So the study basically suggests we need to look elsewhere for the really big scalable solutions.
And where does this study see that massive potential? Which energy sources does it really highlight?
It really zooms in on solar, PV, photovoltaics, and wind energy.
Okay, the big renewables.
Yeah. The researchers point out that the actual resources available, like the amount of sunlight hitting the earth and the wind blowing, it actually exceeds our total global energy demand.
Okay.
And crucially, the costs for solar and wind have just plummeted. They're getting cheaper and cheaper, making them major contenders.
Yeah, that cost drop has been incredible to watch. Now, this study also talks about something called Power to X.
Oh.
PTX. What is that exactly? How does it connect to a global grid idea?
PTX. Yeah, this study explains it as basically a game changer. It's about using electricity, preferably clean electricity, to create other forms of energy or energy carriers.
Okay, so electricity is the starting point.
Exactly. Electricity becomes the central energy carrier. And these PTX technologies, they let us convert that electricity into, say, heat for buildings or clean water through desalination. Or, and this is key, into synthetic fuels and chemicals. Things like green hydrogen, synthetic methane, methanol, ammonia.
So, fuels we can potentially store and transport.
Precisely. And it also includes, just directly electrifying transport electric vehicles.
Oh, yeah.
The study suggests this whole approach could lead to electricity powering almost everything, maybe up to 90% of our total primary energy needs eventually.
90%. That's a profound shift. And this study thinks a system relying so heavily on variable sources like solar and wind, even with PTX, can actually be stable and affordable.
Yes, that's a key confirmation from this study. It argues that a system dominated by VRE, variable renewable energy, can meet sustainability targets.
Okay.
And interestingly, it could even lower the overall cost of energy compared to today's system. Plus, and this is important, it points to co-benefits like new jobs and, crucially, reduced water consumption.
That water point is huge, especially in some parts of the world. Now, I know there are different ideas floating around about what this future grid looks like. Some talk about these massive supergrids, while others focus more on localized, decentralized smart grids. Where does this particular study put its focus?
That's a really important distinction. This study on the techno-economic benefits of a global energy interconnection, it specifically investigates the supergrid concept.
Okay, the big one.
Yeah, the idea of really large-scale, long-distance power lines connecting major regions, potentially across continents.
Right.
The study does acknowledge that whole debate, supergrid versus decentralized smart grids, but its main focus here is really exploring the potential of that massive interconnection.
So this supergrid idea, it's not brand new, is it? Does the study touch on the history here?
It does, actually. It traces the concept back quite a way. Mentions Buckminster Fuller talking about it way back in the 70s.
Wow, okay.
And it highlights the Global Energy Network Institute in the 90s, which really pushed for a global grid running on renewables. And interestingly, it even digs up some older, maybe more ambitious ideas like Atlantropa from the early 20th century.
Atlantropa? What was that?
A pretty wild scheme to dam the Mediterranean Sea for hydropower. Huge environmental consequences, obviously, but it shows the scale of thinking sometimes.
Definitely ambitious.
And the study notes, even back then, a Siemens researcher was already proposing a solar PV-based supergrid. Quite forward-thinking.
Incredible.
Right.
And the study also mentions more recent regional efforts, right? Like linking Europe and North Africa.
Exactly. It discusses various plans there, tapping into the massive hydro potential of the Grand Inga Dam in the Congo. Again, complex project with its own issues.
Sure.
Or using North African sunshine to make hydrogen for Europe. And it mentions desert tech, which got a lot of buzz in the 2000s, focusing initially on large desert solar thermal plants.
Right, I remember desert tech. And this study gives props to some early researchers who really did the groundwork for this kind of modeling.
Absolutely. It specifically credits Gregor Chich's work from the mid-2000s. He was one of the first to really model a 100% renewable system for a huge area, Europe, Western Eurasia, Middle East, North Africa, using detailed hourly data.
And that hourly detail is key, isn't it?
Crucial. This study emphasizes that you need that kind of minute-by-minute, hour-by-hour modeling to really grasp the challenges and the opportunities. You can't just average things out over a year.
Makes sense. So quite a bit of research on connecting regions. Does this study mention work looking at supergrid benefits elsewhere too?
Oh, yes. It makes clear that this isn't just a European or North African idea. This study points to significant research looking into supergrids pretty much everywhere.
Like where?
Well, Europe, Eurasia, MENA, Sub-Saharan Africa, South Asia, SAARC, Northeast Asia, Southeast Asia, Pacific Rim, North America, South America, basically all the major global regions. People are crunching the numbers worldwide.
Okay. And when they looked at these regional benefits, what kind of comparisons did they typically make according to this study?
This study explains that a lot of that prior work used sort of 3 tiers of scenarios.
Okay.
First, just better connections within a region, then looking at connections across a whole country, and finally integrating across a major region like, say, all of Northeast Asia.
And what was the general trend?
The trend they found was that the economic benefits tended to increase as you scaled up the integration right up to that major regional level.
Bigger seemed better, at least up to a point.
Up to that regional point, yeah.
And the cost optimizations this study talks about, what were they trying to minimize in those models?
So the goal in those studies, as outlined here, was usually to minimize the total annual cost of the whole energy system.
Which includes?
Pretty much everything.
Yeah.
The upfront capital costs, CapEx, for building power plants, storage, transmission lines.
Right.
The ongoing operational costs, OpEx, like maintenance. And even things like the costs of ramping power plants up and down quickly to match demand.
Okay.
And critically, all while making sure that supply always meets demand every single hour. That's the constraint.
That sounds incredibly complex to model. Now, this study brings up a really interesting finding. Even when focusing on these huge grids, the cheapest setups seem to have a specific kind of structure. What does it say?
Yeah, this is a key point from those regional studies that this study highlights. It seems the most cost-effective systems tend to be largely decentralized.
Decentralized. Even with supergrids.
Kind of counterintuitive, right? But yeah, meaning a lot of the power generation still happens relatively close to where people actually use it.
Okay.
But, and this is the important part, these decentralized systems are significantly boosted, made more efficient, by having those strong central supergrid connections in place.
So it's a mix.
Exactly. It leads to this idea of a super smart energy system, sort of the best of both worlds. Local generation backed up by wide area transmission.
Interesting. Okay, so with all that background on connecting regions, this study we're focusing on gets to its main goal. What exactly were these researchers trying to figure out?
So the absolute core question of this study on the techno-economic benefits of a global energy interconnection is right there in the title.
Right.
It's asking, What are the actual techno-economic benefits, the costs and technical aspects, if we take that regional integration idea even further?
How much further?
Like either connecting major regions into even bigger super region clusters, or going all the way to a truly globally interconnected energy grid.
Okay, stepping up from regional to super regional or global. Had much work been done on those super regions before this study?
This study notes that research on those bigger clusters was actually pretty limited. The main example that kept coming up was linking Europe, Eurasia, and the Middle East, North Africa, that large landmass. But interestingly, the few studies that did look at these super regions, like in East Asia or the Americas or the Europe-Eurasia MENA bloc, they found surprisingly small additional benefits from connecting beyond the major regional level.
Really? That is counterintuitive.
Yeah.
I'd assume bigger connections always mean more smoothing, more efficiency.
That's what makes this finding, which this study flags, so significant. It suggests there might be a point of diminishing returns when it comes to just transmitting electricity over ever larger areas.
So the sweet spot might be regional.
This study indicates that purely for electricity transmission benefits, the economic optimum for how spread out your power sector integration should be might actually be at that major regional level. Going beyond that into super regions didn't seem to add huge extra value in those analyses.
Okay. And what about the ultimate step, a truly global energy interconnection? Was there much detailed economic and technical work on that before this study?
This study points out that most previous work on a global grid focused more on, like, could we even build it? The technical feasibility.
Right. Can it physically be done?
Yeah. Less focus on the detailed techno-economics. What does it cost versus what do we gain? The paper does mention some earlier work, like one analysis for the Northern Hemisphere, that suggested pretty limited benefits for really long-distance electricity transfer, mainly because transmission gets expensive over vast distances.
Right. Those transmission losses and costs add up.
They certainly do.
So this study really aimed to fill that gap, to do a proper techno-economic assessment of a global grid.
Exactly. What makes this study stand out is that it provides a detailed techno-economic analysis specifically for a global energy interconnection, assuming it's based entirely on 100% renewable electricity.
And modeled in detail.
Yeah, using full hourly resolution for the entire world, which they divided into 23 distinct major regions.
Okay, so they modeled this fully wired up planet. What were the headline results? What did this study find?
So the key finding of this study on the techno-economic benefits of a global energy interconnection using their assumptions for the year 2030 is this. A fully interconnected global system could achieve a levelized cost of electricity, LCOE, basically the average lifetime cost per unit of energy.
Okay, the benchmark cost.
Right, of about 52.5 euros per megawatt hour.
And how does that compare?
Well, they found that's about 4% lower than if those 23 regions just operated as energy islands, completely isolated from each other.
4%?
Yeah.
Okay, so there is a saving, but like you mentioned with the super regions, maybe not a world-changing leap compared to the benefits you get going from isolated countries to regional blocks.
That's precisely the main takeaway from this study, I think. Yes, there's a cost reduction with global electricity interconnection, but the economic advantage seems less pronounced than the benefits we typically see from integrating at national or major regional scales.
Interesting.
The study also found that the total amount of installed generation capacity needed worldwide also drops by a similar amount, about 4%, in that fully connected scenario.
And did the cost of electricity become the same everywhere with this global grid, according to the study? Did it level the playing field?
No, actually. Even with the global interconnection model, this study found the LCOE wasn't uniform across all 23 regions.
Why not?
Mainly because of those transmission costs and losses over long distances. You still have variations. Some regions, like Australia, parts of China and Russia, Western Europe, still showed lower costs in the model.
And others?
Others, like India, Southeast Asia, Japan, Korea, still had relatively higher LCOE even within the interconnected system. The grid doesn't completely erase geographical cost differences.
Okay. What about the energy mix? Did going global change the balance between wind and solar in this study's model?
It shifted things slightly. This study found a small increase in the overall share of wind energy in the globally connected system.
And solar.
Interestingly, the share from solar PV actually decreased slightly in the global case. And as we mentioned, the total amount of electricity generated and the total installed capacity both went down a bit with more interconnection. Oh, and the amount of energy curtailed, basically wasted because you can't use or store it, that only saw a relatively small reduction too.
And energy storage.
Yeah.
batteries, things like that. How did connecting the globe affect the need for storage in this study?
Yeah, this study highlights that classic trade-off between storage and transmission.
Right.
With a global interconnection, the model found that the need for energy storage actually decreased, but only slightly.
So you can move power around instead of storing it all locally.
To some extent, yes. The idea is if one region has excess solar, another might need power, and the grid helps balance that out, reducing the need for quite as much local storage. But the reduction wasn't dramatic in this global model.
Got it. And long-distance transmission itself using HVDC, high voltage direct current. This study factored in losses, right? How big were they?
Yeah, they had specific assumptions. The study used 1.6% loss for every 1,000 kilometers of HVDC line, plus 1.4% loss at each end at the converter stations.
Okay.
And they calculated that on average, for the main interregional connections in their model, the losses were around 4.1% of the power transmitted.
So not insignificant. That loss has to factor into the cost.
Absolutely. It's part of why really long-distance transmission has diminishing returns.
This study apparently has a figure 3 that maps out the beneficial connections. What did that show? Where did the connections make the most sense?
Yeah, figure 3 in the paper is quite revealing. It basically shows that the biggest cost benefits came from connecting regions that are, well, neighbors, geographically close.
Okay, so connecting adjacent regions paid off.
Right. But the model didn't find strong economic benefits for building direct connections across the major oceans, either the Atlantic or the Pacific, or even across the North Pole in this specific 23 regions setup.
So no direct lines from, say, Europe to North America in this model.
Not based on the pure economics in this 2030 scenario, no. Instead, the figure shows sort of three major interconnected clusters forming.
For sure.
The Americas as one block, then Europe, the Middle East, North Africa, and Central Africa as another large interconnected zone, and then Asia as a third.
And were those clusters linked?
Yes, the model did show an economically beneficial interconnection between that Europe-MENA-Africa cluster and the Asia cluster, but not across the oceans.
So it seems the study suggests connecting neighbors is good, maybe connecting large adjacent land masses, but jumping oceans with electricity might not be the best economic bet right now.
That seems to be the implication of this particular modeling exercise, yes.
One last technical point here. The study mentioned how they assessed the solar and wind resources. Could the method they used have affected the results?
It's something they acknowledge. They used an aggregation method, grouping resources across different sized areas. They mentioned this could potentially influence the calculated full load hours, how often the wind turbines or solar panels can run at full power.
So it might slightly overestimate or underestimate potential.
Potentially. They felt the differences were likely within an acceptable range for this kind of study, but they do suggest it's an area where future research could perhaps refine the methodology for even greater accuracy when comparing regions.
Okay. So direct global electricity grid. Some benefits, but maybe not massive compared to regional grids. But this study also looks at another way to connect globally, right? Trading energy products made from electricity.
Exactly. That's a really important part of the paper. It explores the idea that maybe instead of just shipping electrons thousands of miles, we achieve global energy interconnection by trading energy carriers produced using clean electricity.
And this could use existing infrastructure.
Potentially, yes. The study suggests we could leverage some of the infrastructure we already have for transporting fuels, pipelines, ships, though obviously not the stuff designed specifically for coal.
Okay, so what kind of electricity-based products are we talking about here? What has research looked at?
Well, this study mentions other research that's looked into, say, making hydrogen with cheap renewables in Patagonia and shipping it to Japan.
Right, hydrogen as a carrier.
Yeah. And it also points to studies on turning renewable electricity into synthetic natural gas, SNG, liquefying it, and shipping that, for example, from Australia to Northeast Asia.
Okay.
Interestingly, as the study notes, that same research on SNG didn't find a strong economic case for direct electricity transmission between those specific regions.
So maybe shipping the fuel makes more sense than shipping the electrons in some cases.
That's the implication. And this particular study seems quite positive about the potential for this kind of trade more broadly.
What other products does it highlight?
It emphasizes that its own analysis and other recent work finds potentially substantial benefits for international trade in various PTX products. Liquefied SNG, like we mentioned, but also Fischer-Tropsch fuels.
Which can become synthetic diesel or jet fuel.
Exactly. Also methanol, dimethyl ether, and ammonia. These are all energy-dense carriers that can be made from hydrogen, which itself comes from water and renewable electricity.
And we know how to ship most of those already.
That's a big advantage, highlighted in the study we have existing global trade infrastructure for many of these chemical energy carriers.
So it really sounds like while the economics of a purely electrical global grid might be marginal, according to this study, the idea of using clean electricity locally to make tradable fuels could be a much more promising route for global energy sharing.
That definitely seems to be a key insight emerging from this study and related research. It shifts the focus, doesn't it?
It really does. Now, the study is also careful to point out limitations, right? Where does the research still need to go?
Absolutely. It's important context. The study acknowledges we've made huge strides in modeling 100% renewable energy systems. The tools are getting much better, but it points out we still generally lack models that cover the entire energy system, including things like industrial feedstocks, the raw materials industries need, with really high detail in both space and time, especially for a truly global interconnection.
So we need more comprehensive, more granular models.
Exactly. To really understand the transition pathways and the interplay between all the different sectors and regions at a global scale.
And looking ahead, what role does this study see for different energy carriers in that future system?
Well, it reinforces the common view that electricity is likely to be dominant, both as the primary energy source and for end uses. And it really underlines the crucial, versatile role of hydrogen.
But trading hydrogen globally, is that a sure thing?
That's where the study notes some uncertainty. How much hydrogen actually gets treated globally depends heavily on advancements in transport technology, making it cheaper and more efficient to move, especially as a liquid. That's still a hurdle.
Okay. And those other synthetic fuels we talked about, SNG, methanol, ammonia, does the study see them playing a big role long term?
Yes, it identifies those liquefied SNG, synthetic liquids, methanol, ammonia as key future energy carriers alongside hydrogen and electricity.
So future models need to include all of them.
Definitely. The study argues that when we think about global energy interconnection, we really need comprehensive models that look at the connections through all these different carriers, not just power lines.
So more detail needed. What other specific areas does the study suggest need more work?
It really emphasizes the need for these high granularity global models we just discussed, covering power and other energy carriers.
Right?
And it also stresses how important it is to track the rapidly falling costs of renewable electricity and, crucially, electrolyzers.
The machines that make hydrogen.
Exactly, because how quickly those costs fall will massively impact how viable all these PTX routes are, and that will shape the patterns of global energy trade.
And those falling costs of renewables and storage also compete directly with building long power lines, don't they? The study mentions that competition.
Yes, that's a critical point. Long-distance electricity transmission is facing increasing competition from just building more local, low-cost renewables and pairing them with increasingly cheap local storage like batteries.
Because the costs are dropping at different rates.
Exactly. Solar, wind, batteries, electrolyzers, their costs seem to be falling much faster following steeper learning curves than the cost of building huge HVDC transmission lines. So the study concludes that really understanding these different long-term cost trends, these sensitivities, is vital for figuring out where international cooperation on energy trade will actually be most beneficial down the road.
This has been a fascinating look on the techno-economic benefits of a global energy interconnection. If we were to boil down the main conclusions this study offers, what would they be?
Okay, well, this study on the techno-economic benefits of a global energy interconnection, I think it concludes that yes, a fully interconnected global electricity system does show some modest cost savings, around 4% in their model, and allows for slightly less total generation capacity compared to isolated systems. But those benefits seem less significant than the advantages we already see from connecting energy systems at the major regional level.
So the biggest bang for the buck might be regional integration.
The research presented in this study really points towards that the primary benefits of power system integration might well be realized at that major regional scale.
And the future of long-distance energy sharing might actually look different, more about fuels.
Yes, the study really emphasizes the significant potential it sees for future long-distance energy trade through these more energy-dense carriers, things like synthetic natural gas, synthetic liquid fuels, methanol, ammonia, maybe hydrogen itself if transport improves.
Right, using clean electricity to make something shippable.
Exactly. That seems to be where more substantial global trade benefits might lie, according to this line of research.
And clearly, as the study points out, there's still more work to be done here, more research needed.
Absolutely. This study finishes by calling for more comprehensive, higher resolution global energy interconnection research analysis that really integrates all the key energy carriers to give us a clearer picture of the true potential and the best pathways forward.
Okay, so here's a final thought to leave our listeners with. Considering the, let's say, marginal economic benefits found on the techno-economic benefits of a global energy interconnection for a truly global electricity grid, compared to the clear advantages of regional cooperation and this emerging potential for global trade in synthetic fuels. What kind of international partnerships do you think will actually be the most crucial as we try to build a sustainable energy future? It definitely gives you something to think about.
It certainly does.
Thanks for joining us for this deep dive on the techno-economic benefits of a global energy interconnection.